Welcome to part 1 on right triangle trigonometry. In this section, we'll be looking at right triangle base definitions of trigonometric ratios using a calculator, and we'll look at an application. So let's start with right triangle trigonometry. Right triangle base definitions of trigonometric ratios are as follows. We need to consider an acute angle. Remember, an acute angle is less than 90. Theta, we'll call the angle theta, in the standard position. Create a right triangle as shown with hypotenuse r. The side of length x is called the side adjacent to angle theta. The side of length y is called the side opposite to angle theta. And recall the Pythagorean Theorem. If it's been a little bit, the Pythagorean Theorem is a squared plus b squared equals c squared. Or more appropriately for our trigonometry, x squared plus y squared equals r squared. If we solve this for r, we have the following. If we take the square root of both sides, we would have plus or minus, and algebraically it would be plus or minus, the square root of x squared plus y squared. But remember that a radius can't be negative, at least at this point in the quarter, and so we're just going to leave it as r equals positive square root of x squared plus y squared. So now if we look at this graph, we can see that we have an x coordinate horizontally to the right, a y coordinate that is formed by the diagonal angle. So y is this section here that is the height of the triangle. And r is the longest side. So what I would recommend is for you to pretend you are standing at the corner of the triangle. There you are, standing there at the corner, where the angle is theta. The first thing you should do is identify where your right triangle angle is. Make sure that you've identified that first before you find anything else. If you look out across the triangle, the side that you are looking straight across at is always going to be your opposite side. The hypotenuse, on the other hand, is always going to be the longest side. And the adjacent side is the one you can walk onto. So if you just start walking forward, dun, 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 this is your adjacent side. The one that you can walk right onto as you're moving through your, like walking toward your angle theta or into the little Greek letter. This is probably the most challenging thing to do when you're asked to find the different ratios for a triangle, and you'll know what that means here in a minute. But if you think of yourself standing at the angle, it's going to make your life so much easier. Now, if you think of x squared plus y squared equals r squared, that's going to be on a unit circle. The radius is always going to be 1. So we could think of, in future videos, we can think of this as x squared plus y squared equals 1, because if we treat this as a unit circle, it's just going to rotate through this angle like we've shown in previous videos. Now let's look at these triangles. Using this triangle, we define the 6 trigonometric ratios. And I am going to highlight this, and you should too, because these are things you absolutely must memorize. There is absolutely no way around it. You must memorize all of them. So sine of theta is always going to be opposite over hypotenuse. And if we look at and compare these two triangles here above, we can see that opposite is your y, cutting through that angle theta toward y. We see y over the hypotenuse. The longest side is r, the radius. So opposite over hypotenuse will correspond to y over r. Cosine of theta is adjacent, the side you can walk on, adjacent, which is coordinate x, over hypotenuse, the longest side, and that corresponds to x over r. Tangent of theta is opposite over adjacent, which is y over x. Now, I think that that's interesting because it's kind of like the slope, rise over run, y over x. Just putting that out there. And now I want you to notice the correlation between sine of theta and cosecant, CSC theta, cosecant theta. Notice that the cosecant theta is the reciprocal of the sine theta function. So if you can remember sine, cosine, and tangent, and that sine flipped over is cosecant, cosine flipped over is secant, and tangent flipped over is cotangent, you are going to be in such good shape. So notice that all these trig ratios in the second row are the reciprocals. They're flipped over versions of the ratios in the first row. So that's one way to memorize this, but go ahead and put these on little note cards until you get it figured out. So there's one more thing I want to point out in this video that's interesting. I'm not going to emphasize this a ton, at least right away, but I do want you to note something interesting that occurs with a triangle. If we look at the distance horizontally, we have this C prime here for the first little distance, and then another distance further would give you C. When you have the same angle starting at the origin and it's rotating counterclockwise through, and y is the height, and we'll say that r prime is this first coordinate point and r is the second coordinate point way up here at the top of the triangle, then we can say that if you have a triangle ORC, it is approximately equal to OR prime C prime. So it's approximately equal to this little triangle that is down here. And we can say that the ratios, if we look at this, the ratios are going to be the same. They're going to be equivalent. For O to R prime divided by O to R that ratio is going to be equivalent to O to C prime divided by O to C. This is just an interesting relationship, and it's important to note that the thing that makes this triangle ratio constant is theta. So as long as theta is held constant, as it says right here, the ratios on your triangle are going to be equivalent.